All right, good afternoon. Hopefully this is working. I had a bunch of technical difficulties because I left my equipment at home and couldn't record here. So I'm borrowing Miss Apple's setup and hopefully we can get through this. So I'm on part B for the titration pre-lab so that you guys can see one worked out. And hopefully after I go slowly through all of this, the numbers again will make sense. This one is a great example to show all the teeny little details of things that we need to remember. Okay, so first I need to select a pen so I can write. That would be helpful. Okay, so here we have our dichromate, and we should recognize now that this is -2 and this is -14. And then I have chromium, which is going to be +6, and then this is going to be +12. And I give an overall charge of -2, which is what the dichromate ion is. Then I have iron with a +2 charge. I have chromium +3, and then I have iron +3 also. So I'm going to bracket this up like we've been doing in class. The chromium you can see is changing. Remember, we go back to its oxidation state. This is its oxidation state, +6 to +3. So that means it's gaining electrons, which means that it is reduction. Then up here I have iron going from +2 to +3, so that is a loss of electrons, so that is going to be oxidation. Hopefully you're okay with those parts. So now remember, the next part is we are going to bring each half reaction down. The neater you are, the easier it's going to be to catch your mistakes. So I have iron +2, and it's going over to iron +3. Now remember, the first thing is I want to balance the elements except for hydrogen and oxygen. So I have one iron, one iron. Now my charges are that I have +2 to +3. So to balance that out, I'm going to add one electron over here. So now I have a neutral reaction. So that's the easy part. So now I need to pull down my dichromate. So my dichromate, Cr2O7 with a -2 ion charge, and that is going to go to chromium with a +3 charge. Remember, you want to pull down the ones that are changing. So if I select a different pen color here, we have our chromium that has a +6 charge. That's its oxidation state. Now we're still going to have to do all the multiplying in here, but we're going to do that at the end because we are going to be adding some balancing. So if I take a look here, you can see that I have 2 chromium. So I want to put a 2 right here, so I have 2 chromium. Now that's going to change its overall number of electrons that are leaving my system. So 2 times a +3 is +6. Again, I don't need anything out here, so 2 times +6 is +12. Okay, now I have my elements balanced except for hydrogen and oxygen, so now I'm going to balance my oxygen by adding water. So I'm going to add 7 waters over here because I have 7 oxygen. So 7, that's a 7, H2Os. And then I balance my hydrogen with hydrogen ions. So make sure you get this lingo down. So 7 times 2 is going to be 14 hydrogens. And I can pause, hold on. Did you find what you needed? Okay, so I have 14 hydrogens. All right. Now if I take a look, I have to see what my charges, how my charges have changed. So when I look at this, I have +12 to +6, and if you didn't multiply this out, then you would be having trouble because you'd be looking at 12 to 3. It's 12 to 6. So I have to add my 6 electrons to this side. Okay, and now I need to balance this out. What? No, I do not want to change the color scheme. Excuse me for that. All right, so now if I take a look at this, I have 6 electrons here, I have 1 electron here, so I need to balance this out. So I'm going to multiply this whole thing by 6. And then I'm going to write my resulting equation down. So if I take a look, and I have 6 electrons now because I multiplied this by 6, or I could easily put my 6 here, my 6 here, and then I have my 6 electrons. You can see that. Now I'm going to write all of my resulting items down below as my balanced equation, and you need to remember that you have to put all of your ion charges and whether it is aqueous or solid or liquid. Remember, they're all at room temperature. So hydrogen ions, it's an ion, so we know that is aqueous in water. I have 6 iron 2 ions, also aqueous. I have a single dichromate ion with a -2 charge that is also aqueous. Trouble with that. And then I have 6 irons over here with a +3 charge, and that is aqueous. I have 2 chromate ions with a +3 charge, that is aqueous. And I have 7 waters, and we are at room temperature, so I know that that is in the liquid state. Okay, now we have our balanced equation. That's a lot of work, but we're not done yet. So now we need to go back and we need to read what it says. So it says what volume of 0.0150 molarity of the solution, remember that this is a spectator ion, so we don't have to worry about the potassium, would it take to do the same titration reaction in acid? Okay, so I have my balanced equation. I am trying, excuse me, I'm trying to find volume. There goes the bell. So now I'm skipping lunch for you guys. Maybe someone needs to bring me a treat tomorrow. It's teasing. Okay, so now I want to find my volume here. So that's going to be my X in liters. And from the problem before, you found out, or we know, let's see, how did I... Okay, sorry, not from before, it's given in the problem, that you are given, can you close my door? Thanks. Okay, that you are given 0.0, you know that this is the molarity of this solution. And again, I know it says potassium dichromate, but we can drop that and it's the same thing. So what we're going to do is we are going to take the moles of iron, because we have the moles of iron from part A that you already calculated. So somewhere in your calculations, you should see this, that you have 0.00223 moles of iron. Iron 2. Well, I'm just going to use my stoichiometry to get 2 moles of my dichromate, because if I have my molarity, which is moles over liters, I find the moles that I need, I should be able to find out my volume. So unknown over known, I have 1 mole of my dichromate solution and 6 moles of my iron. And that is going to give me 3.72 times 10 to the -4th moles of my dichromate. Well, then I can just go ahead and figure out the rest. If I set up a quick proportion, you should be able to see this. Or I can just simply, actually I could just simply multiply my molarity times my moles. No, I can't do that because it's a molarity, sorry, scratch what I just said. You need to take and understand that it's 0.0150. We know that that is moles in 1 liter. When you are ever given molarity, we know that it is in 1 liter. Excuse my chicken scratch here. I'm trying to go fast. Then I have my moles that I just calculated up here, 3.72 times 10 to the -4th moles. That's molarity over, I don't know the amount of volume. Cross multiply and divide, and you should get the answer that I gave you, which I moved over to 24.8 milliliters of my dichromate solution. So this part right here that I just did should not be anything new. It is still based upon molarity and that we've done before and a little bit of stoichiometry. The hard part is making sure that you guys can get to your redox balanced equation and be able to use the stoichiometry. All right, hopefully next time I make a recording it won't be so mumble jumble, but I'm in a hurry and I wanted to get this done for you guys. And I will see you happy smiling faces tomorrow in class. Have a wonderful night.